Alright, so in this video we're going to go over ratios, proportions, and a little bit of probability. So let's go ahead and jump right into ratios. Now, a ratio is a way of comparing two different things. So, for example, say you're a soccer player and you take 10 penalty kicks. And 8 of those result in a goal. So the ratio of goals to total kicks taken would be equal to 8 to 10. So ratios are denoted by either a colon or a fraction. And either is correct. But when you say it, you always say 8 to 10. 8 to 10. So the colon, you say the word 2, or this fraction sign, you say the word 2. Say, for example, you wanted to know the ratio of goals to misses. We know that we took 10 penalty kicks and we made 8, so therefore we can make the educated guess that we missed 2. So that ratio of goals is going to be 8 to 2. So another thing that ratios are used for are unit rates, which can be important in things like part-time jobs. A unit rate would be the amount of money you earn per hour. It can be trying to figure out your speed when you're on a road trip, so how many miles you're traveling in 1 hour. You can even use it for other things like when you're shopping. A lot of times you want to compare two different items, and so you want to know the dollar per ounce of a certain item so you can compare it to a different item. So, for example, if we were trying to compare, let's just say, two different kinds of laundry detergent. And detergent number 1, its size is 20 ounces. And it costs $6. And then detergent number 2, its size is 64 ounces. And its price is $15. And you want to know if detergent number 1 or detergent number 2 is the better price. So we want to know the dollar per ounce of each laundry detergent. So for number 1, all you're going to do is you're going to take your dollar amount and then divide it by its size. See how we have dollars on top here and ounces on the bottom here? We want the same thing to happen when we're doing our math. And when you perform that math, you get that it is 30 cents per ounce for number 1. And for number 2, again, $15 over 64 ounces. And this ends up being 23 cents per ounce. So therefore, laundry detergent number 2 is cheaper, and that's the one that you're going to want to buy. All right, let's talk now a little bit about solving proportions. So a lot of times you'll end up with a proportion that looks like, so let's say x over 10 is equal to 20 over 30. What you're going to do in this case is you're going to use what's called the cross product. So you're going to multiply these together and set them equal to these multiplied together. So we're going to have x times 30 equals 10 times 20. So we're going to end up with 30x equals 200. Divide both sides by 30. You end up with x equals 20 divided by 3, which is 6.67. Again, that's all the cross product is. You're just multiplying this, setting equal to those multiplied together, and then solving for x like we have done previously when you solve an equation. All right. Another thing that, I guess a couple applications for this cross product are in comparing things like triangles, which can be pretty useful. So if you've got two triangles that are similar, that's what that symbol means, similar, in that all of these angles are the same, just their side lengths differ. But you can set up at a proportion just label these sides really fast. So capital letters for the bigger triangle, lowercase letters for the smaller triangle. So this side is going to be similar to this side. This side is going to be similar to this side. This side is going to be similar to this side, in that their proportions have to be consistent. So you can set up things like a over b is going to be equal to a over b. And again, use your cross product to solve for your unknown in that case. Or you can also do things like a over a equals b over b equals c over capital C. But again, notice in all of these examples that your top and bottom have to be consistent. So see how this is the same letter just for different triangles? Again, same letter, different triangles. Or you can have both your lowercase on top, both your capital on bottom, lowercase on top, capital on bottom. It doesn't matter how you set it up, just as long as you're consistent in which side of the fraction you're putting certain things. So for example, if we set this up so we know that b equals 4, a equals 3, and c equals 5, and we know that this equals 2, and we don't know A and C, then we can go ahead and use one of these proportions to figure that out. So the only thing we know in our smaller triangle is B. So we're going to go ahead and have to use that. We're going to have to use B on one side of our proportion. So we'll go ahead and do little b over big B is equal to, we want to find side A first. So we're going to do little a over big A. So that's going to be equal to 2 over 4 is equal to little a over 3. Do our cross product, so 2 times 3 equals 4 times a, so 6 equals 4a, so a equals 6 over 4, which is equal to 3/2. All right, and then we can go ahead and use the same thing for side C, except we're going to place this with little c and then big C. So we're going to have 2 over 4 equals c over 5. Again, do your cross product, so 2 times 5 equals 4 times c. 10 equals 4c. So c equals 10 over 4, which is going to be equal to 5/2. All right, so it's as simple as that. Just make sure that you line these up correctly and you don't get them confused. Just stay consistent. All right, so another thing that you can use proportions for are things like scaled drawings. So say you're looking at a map, and the map at the bottom has this scale saying that 1 inch equals 5 miles. Now you measure on that map with your ruler a distance between two cities, city A and city B, and you measure this distance as being 3 inches, but you want to know the actual distance in real life. You can go ahead and use this proportion. So we know that 1 inch is equal to 5 miles, and we measured 3 inches. Now we've got inches in the top on this side of our proportion, so we've got to have inches in the top on that side of our proportion. So we measured 3 inches, and we want to know how many miles that is in real life. So again, you can just use your cross product. So 1 times x equals 5 times 3, so x equals 15 miles. And it's as simple as that for scaled drawings.